in this video, I just want to do a few examples of polynomials with more than one variable. We've seen it a little bit, but not a ton. So I thought it'd be good to do a couple extra examples here. So here you can see a subtraction example. In addition, we work very, very similar. The only difference with subtraction is that, remember, we do have to distribute that negative. So as I go through here, I'm going to make sure I distribute that subtraction sign to all parts of my second polynomial. So I have 5x cubed minus 9x squared y plus 3xy squared minus 4, and then minus 3x cubed. This becomes a plus 6x squared y, a plus 2xy squared, and a minus 3. Now, everything is really the same here if you have more than one variable. You just have to be a little bit more careful about combining the right like terms. So I think my x cubed terms are pretty clear, right? X cubed minus 3x cubed, that would be 2x cubed. I'm actually just going to cross them out when I'm done because I have quite a lot going on here. Now, my next set is the x squared y and xy squared. You do want to be really careful here. So these two are unlike to each other. I know they look very similar. They both have x and y, and they both have a square. But notice how that square moves. Here it's on the x, here it's on the y. So these two are not like terms. I cannot combine them. What I can combine, though, is this one with this one. So notice how these have the exact same variable parts. They both have the square on the x and then a y. So those are your like terms here. Negative 9 plus 3 is minus or negative. Negative 9 plus 6, excuse me, is minus 3. I'm doing the work too fast. And then your variable part stays the same. Also notice that this and this are the same. So see how they have xy squared and this one has xy squared. Exactly the same. They both have an x, they both have a y squared. So 3 plus 2 is 5. And then finally, minus 4 and minus 3 is minus 7. So your processes are exactly the same. You just have to be a little bit more careful. Okay, let's do an example with multiplying. Maybe if I have x plus 4y times 3x minus 5y. Now the process is the same here. You can use FOIL method, you can use the distribution, whatever you want to do. In either case, you would still start with the x times the 3x first. So x times 3x, I'm going to write this one out just so you can see it a little bit clearer, is going to be 3x squared. Then if you do your outside terms, you're doing x times a negative or a minus 5y. So here, we just like to put our numbers out front, and then x times y is just xy. On the inside, you have 4y times 3x. Everything is positive. 4 times 3 is 12. And then yx and xy are the same thing. So you can write it in any order you like. We typically like things in alphabetical order. So I'm going to write the y first. And then you have positive 4y times that negative 5y. 4 times negative 5 is negative 20, and y times y is y squared. Now you do have some like terms. Again, something like xy and yx are the same thing. Multiplication is commutative, so you can change the order. So these are like terms. And we have 3x squared plus 7xy minus 20y squared. I will note, if you wrote your answer as 7yx in the middle, that's still correct. Okay. And let's just do one more. So maybe 5x plus 3y squared. So you do have a square formula. If you want to use it, you're welcome to look it up. I like to just write it out. I think it's just as easy. And you're going to write the same factor twice because it's squared. And again, now you're going to distribute or think of it as foiling, whichever way works better for you. Here, we'll just do this one more mentally. So 5x times 5x, that would be 25x squared. 5x times 3y. 5 times 3 is 15, and then you have an x and a y. On the inside, 3y times 5x. Again, 5 times 3 is 15, and then I have a y and an x. And then at the end, 3 times 3 is 9, y times y is y squared. Combine your like terms. Again, you do want to check with squares and things, you do typically have those like terms in the middle. If you have more than one variable, it could work out where you actually don't have any like terms. So just always check at the end and see if there's anything else you can do. Here we can combine those together to get 30xy. And that would be our final result. So if you do see some examples where you have multiple variables, just use what you already know. So you know how to add, you know how to subtract, you know how to multiply, and just spend a little bit extra time being careful. So watching your exponents, making sure you have the right like terms, etc. But the general processes are going to stay the same.